a key concept, of course, is the selection probability. And when you sample individuals, when you conduct a survey, you should always think, what is people's selection probability? Think of it as a number that is pinned on everybody's back, and that gives a probability of being selected. For example, 0.03 means that that person has a 3% chance of landing in the sample that you are taking. It should be known, or it should be knowable at some point, maybe not now, but in a well-defined point in time. For example, at the end of the year, think of the example of the general practitioner that we gave before. The number should be known, or at least one should be able to consistently estimate it. Very important, and often there is confusion about it, but if this would not be the case, a large part of the course would actually not exist. The selection probability does not need to be constant. So it may be known a priori. You may estimate it at the time of analysis, and the number may vary from contingent to contingent, for example, from stratum to stratum, or it may vary from individual to individual even. Especially with dynamic lists, this is something you would expect. Okay, so as we said, the time that a patient visits the general practitioner, or the visit of the patient to the general practitioner, is a good example. Many people think, hey, but isn't like if a patient sees, let's say, 10,000 patients in a year, or a general practice, isn't the selection probability 1 per 10,000? No, because this starts from the unit visit. But if we start from the unit patient, we should realize that some patients visit the doctor more than once, some every week, some twice a year. So at the same time, the selection probability may be very closely linked to your health. The more you go to the doctor, the more there is a chance that there is a health-related problem. So if you don't take that probability into account and you treat everybody in the same way, you might well overestimate or underestimate some health-related issues. So if there are external factors, especially initiatives by the respondent, that interfere with the chance of being selected, you may get misrepresentation bias. People who come to a meeting, if that is just for interested people, you may go to a meeting for volunteers in model railways and then do a survey about whether they like it or no, and say, hey, 100% of the population likes model railways. No, but the people in the room do, because that is a very, very select, as we sometimes say, sample. In a meeting, even though it may be fairly representative, some people will speak up more than the other. That may have to do with cultural differences, with whatever personality differences. And if that's what you're investigating, you may have a completely different perspective. People who volunteer, people with easy access, etc. Some of these have always been on the table, but are more so now because there is so many web-based polling and surveying that we have to be very careful with that. So, in summary, everybody has the number on their back, at least in theory, and sometimes explicitly known at a certain point, describing their selection probability. And those numbers are used when we draw from the population. Of course, we're not going to physically look at people's numbers on their back, but that's the concept. There is such a probability. A very problematic number in terms of probabilities is the number 0. We don't want that, because 0 means people have no chance of landing in the sample. And if that is a sufficiently large group of people that is sufficiently different from the others, that is actually the group that is in the population but not in the sample frame. Then we have a problem. Good. Next, sample units. A study can have indeed units at several levels at the same time. So we always have to define very carefully what we mean by our sampling units. For example, in the Belgian Health Interview Survey, what are the units? The towns, or the households, or the individuals? Well, all three. They're all three units, and one is not right or wrong. It just depends on what you look at. Because you may have interest in individuals, and then the units are going to be individuals for you for analysis. But you must know that those individuals came into being by passing through towns and households. But sometimes you're interested in households as well. So even the units then in your analysis are diverse. And you may do a household level analysis, and you may do an individual level analysis. Both make sense, both may be answering research questions, but different ones. Well, what are units? About everything you can imagine. Lots, by that we mean building lots, plots they say sometimes, buildings, dwellings, apartments, property, whatever, individuals, children, families, households, etc. Question. Are the provinces units in the Belgian Health Interview Survey? No, they are strata, and we keep that separate because the consequence of sampling from units and then units within units within units, that is multi-state sampling, and that's a different ballgame from stratification, where we split the population in subpopulations and take it from there. There are fundamental differences also in terms of consequences on precision, etc. All right. We will leave it at that now, and in the next session, in the next web lecture, we will start with 3.10, where we will spend a little bit of time on defining the notation, and even though you may know notation and think you know notation, it is usually used a little bit differently in a survey context.